Good afternoon, everyone. Welcome to session 425, Performance in Document-Centric COCO Applications. My name is Mark Petrelli. I'm an engineer in the COCO Frameworks group. Today I'm going to talk about how to make NS document-based applications faster. I'm going to talk about what we're doing to COCO in Snow Leopard, and I'm going to talk about what you can do to your applications to respond and to take advantage of what we're doing. The four big topics I'm going to cover are concurrent document opening, having more than one document open at once using multiple threads. NS URL is the one true representation of file locations and the performance implications of that. NS file wrapper improvements and how to use them. And I'm going to finish up with something that applies to every kind of application, but it's particularly easy to adopt in NS document-based applications. Sudden termination, so your application doesn't slow down system shutdown. First off, concurrent document opening. As you might have heard in some of the sessions that have already taken place, we're making a big effort to take advantage of multiple cores in Snow Leopard. And document opening is a pretty obvious candidate for this because, this is something big and blocky, and to, have it happen on each document being opened gets its own core basically, it's pretty easy to accomplish this. It's pretty easy to accomplish. And the results, the first one is responsiveness. Why block the UI if a document takes a long time while you're trying to do other stuff? And also the total time. When you're opening up a big batch of documents, if you can spread out the work, the user will end up waiting less. So the first bit of new API I'm talking about today is a new class method on NS document called can concurrently read documents of type. And the default implementation returns no, but you can override it in your NS document subclasses to return yes. And we pass in the type name, so if you have implementation limitations that prevent you from taking advantage of this in some corner cases, you can still take advantage of it in the cases that really matter. So we let you know what the NS document is going to be asked to do if it says yes. And when you turn this on, your document reading code must be thread safe. So if you have shared caches or something like that that are accessed by multiple NS documents, you have to make sure that's thread safe. Though that's not that common really. I think we're discovering that opening a document is mostly a pretty self-contained blob of objects that gets created during that process. So what happens when you return yes from that method? NS document controller, which is what's in charge of controlling the opening of documents, creates multiple NS operations and puts them in a concurrent NS operation queue. Each one of these operations will execute on a non-main thread. And which thread, you're not supposed to care. All you know is that it's not the main thread. So NS operation takes care of this management of threads for you. And what ends up being done by the concurrent operations that we're talking about? Well, it starts off with NS document controller sending itself make document with contents of URL of type. And that allocates an NS document instance and sends it init with contents of URL of type error. And typically that boils down to an invocation of read from URL of type error. So the document is allocated and initialized, which implies reading on, in a concurrent NS operation. So what's still done on the main thread in this scenario? We don't try to do absolutely everything on these background threads. Background operations. You're not supposed to care about the thread so much. But what's still done on the main thread is after documents have been read, that's when NS document gets sent make window controllers to build up its user interface and show windows. We still do that on the main thread. And that's okay because document reading is the part that we really want to make concurrent. It's the unbounded part. If the document is very long, that can take a long time. Setting up the UI is pretty much a constant operation typically. And also we're doing that way because window ordering has to be deterministic. We have to do some stuff to make sure that windows don't pop up in random order because some documents open up faster than others. And, but we're still exploring it. Maybe someday we'll do more in the concurrent operations to get more performance. So today, let me show you a demo of concurrent document opening in TextEdit. So I have a version of TextEdit that we've enabled this switch on, concurrently opening documents. And we just added a simple file menu here to control what it's doing. So I'll just pick a big blob of text edit documents. And this is the non-concurrent case. And we'll open them up. And it's pretty quick, but wait, it's not done. The spinning pizza of death. It was all blocked up for a minute there. So that's not really that good. We can do better than that. So close all those and just turn on this little switch. And again, that just controls what our subclass, our NS document subclasses can concurrently read documents of types override does. And open up the same batch. And the UI isn't blocked. We can start getting work done, even though it took a little while for this last one, which is really big, to open up. So it was pretty neat. It was better responsiveness. And if documents were huge, it would have been much better responsiveness. So, slides. So opening documents concurrently is a pretty easy performance win most of the time. So I want you to check this out. There are other ways to speed up document opening, by the way, including the concept of incremental reading, which Doug Davidson presented just an hour and a half ago in polishing your COCO applications. So next thing to talk about is NSURLs everywhere. This is something we introduced in COCO What's New, and there was a file system efficiency session yesterday where this was discussed. But let's discuss it some more. Our goal is that we're trying to eliminate needless I/O in Snow Leopard. And we have to admit COCO has some room for improvement in this area. So things like redundant lookup of file attributes, and especially the killer is conversion of paths to FSREFs and back. If you saw Chris Lynn talking yesterday in his session, he had some measurements of opening something in preview, and it was like 10 conversions of paths to FSREFs and 4 from FSREFs to paths, or maybe it was the other way around. But it was the same path and the same FSREF over and over again. So we want to deal with that issue. So, and some of you might be wondering, if you're old Carbon hands and you know that things like FSREFs aren't really exposed in the COCO API, you're wondering, COCO uses FSREFs? And we do. You're not supposed to notice this, but we use it for, except the effects of it, we use it for NS document file tracking. So when the user moves or renames a document and then switches back to the application, we update the window title and the icon and stuff like that. And also we use it to take advantage of the functionality that are in frameworks below us, like core services. And what we're ending up doing in Snow Leopard is using NSURLs everywhere. So no more paths, no more FSREFs. NSURL is the one type that we use for locating files. And this is just a continuation of a direction that we've been taking for a very long time now. We've always been moving toward NSURLs. Our APIs, the lower level stuff like attributed string and data and dictionary, and even higher level stuff like path control have been dealing in NSURLs for a while now, even in classes that only handle file URLs. Even when we're not taking advantage of the fact that a URL can point to stuff that's out on the web somewhere, it's still the good simple type to use. And especially NS document and document controller, we started using it in Tiger when we published a bunch of new methods and deprecated a bunch of old path-taking methods. So now that we're standardizing on NSURL, we can do new things that solve old performance problems, like attribute caching. Here's a little AppKit secret for you. AppKit, for a couple of releases now, has internally been doing a bunch of caching of attributes of files, things like getting their names and their icons and their modification dates and stuff like that. So that horror show that Chris Lynn showed you yesterday with just tons of FS usage when opening a document, that's after optimizing this stuff and putting performance tricks into AppKit. So, but where this falls short is that's internal. And we don't even use it pervasively in our own frameworks. And the worst part is it's not open to use. So when your code is pinging at a file, it can't get the values that are already in some cache somewhere. So what we're doing new in Snow Leopard is we're adding a bunch of new API to NSURL for getting and setting what we call resource values. URLs locate resources, and resource values are the values of the attributes of those resources. So a couple of the methods look like get resource value for key error, or a batched version of that, resource values for keys error. And of course, there's setters, too. And there's a big list of keys that are supported. You can look at them in the public header on your WWDC seed for Snow Leopard. It's in Foundation NSURL. And some of these are pretty, primitive things like getting the name, but some of them, have more logic there, like getting the localized name, which takes into account, file system localization that we do, file name localization that we do, and also whether or not the file name extension is hidden and stuff like that. And even, there's even a key for getting the type identifier, the uniform type identifier. So that's something that's, computed. That's not actually stored in any file system. So there are about 40 of these keys. I'm just showing you 4 of them here on this slide. So have a look at that. And what I want you to know while you're writing your own code is that if you go straight to the Darwin APIs, you're missing out on this NSURL level caching that we're doing. So we want to funnel everything through NSURL for getting at this kind of stuff. And you should too. We'll all be using the same cache and reducing the amount of I/O and hitting the disk or hitting the network server or whatever that happens. So this is all discussed in very great detail yesterday in session 375, using file system APIs efficiently. So we're standardizing on NSURL, totally standardizing and adding features, and as a result, we can focus and make more use of NSURL now in Cocoa. So NSDocument and Document Controller have been using it since Tiger, when we deprecated a bunch of path-based APIs. Very nice bit of foresight on our part. I'm glad we made that choice. Otherwise, we'd have a bunch of stuff to redo right now. But that deprecation of those old path-based APIs, which not only were path-based, but had not very good error handling. They didn't deal in the NS error mechanism that we added. Those have been deprecated for a while now. So if you haven't updated your application, now is probably a pretty good time. And also, we're adding NSURL-based API to things like NSBundle and NSFile Manager and NSFile Wrapper that I'll spend some time talking about. And we have plans to do this to more classes by the time we ship. So what this means, if you've written Cocoa apps and you found yourself for some reason or other having to go to the lower level core services API because you had to do something that required FSREFs, you're not going to have to do that anymore. So FSREFs can go away now. And good, because the cost of conversion between them and paths was a performance problem. And just a conceptual problem, you're doing Cocoa programming and you find that there's something that's supported by Mac OS X and it's not in Cocoa. You got to read a whole other set of documentation and stuff like that. And then you have to write code that converts between these different types. This is the impedance mismatch that we talk about. So that's going to go away. Some of you might be wondering about aliases. If you think about FSREFs, you very often also think about aliases, which in a sense are the persistent representation of FSREFs with a lot of policy and stuff built in. Another little AppKit secret is that we have been going out of our way to resolve them at all the right times in AppKit. So like when you pick an alias file in the open panel, we resolve it before we return it from the public NS open panel API that gives you a path or a URL now. So, but if you wanted to do more with that, you had specific needs, you wanted to take advantage of the features of aliases, which have always been very useful, you've had to go to core services to do more with them, and that was sort of a drag. So, but now NSURL has support for a replacement for that called bookmarks, which have a bunch of new features and are easier to work with. So that was also discussed in yesterday's Using File System APIs Efficiently session, and I highly recommend your having gone to that session. It was pretty good, but it'll be up on iTunes U also for after the show. So I tell you that FSREFs are going away, and for old carbon hands or people who had to dig into them just in Cocoa apps, you might protest, but FSREFs were good for some things, and they were good for some things. NSURLs as a replacement for it. NSURLs for files are just fancy paths, the path with file : / and localhost, I think, at the front of it. So, and FSREFs did something big that paths can't. They can point to the same file even when the user moves or renames it. So, and that's pretty useful. Like I said, NSDocument takes advantage of this to do good user interface for the user. So the answer to that is yes, that was good functionality, and we are preserving that by putting it into NSURL. There's going to be a new kind of file URL. It still uses the file : scheme. And the paths that you see in these URLs start with file, and the rest of it is just mumbo jumbo. It's, Chris put it on a slide yesterday, and you will see these while you're debugging, but you're not supposed to pick these apart or, God forbid, try and build one by hand. We have API to do that. So, and we call them file reference URLs, in contrast with the file path URLs that we've all been working with all this time. Both kinds work in all the same places. Is file URL returns yes for both, and the path method works for both. And you can convert them between them using the file reference URL and file path URL. These are messages that you send to an NSURL to get one of the right kind. But most of the time, you don't care which kind you're working with. Everywhere that takes an NSURL and NS file wrapper and NS file manager and NS document and all the rest, they're supposed to just deal with both kinds. So this new kind of URL for FSREF-like behavior, NS document is going to switch over to that for its document tracking behavior. And NS file wrapper too. I'm going to be talking about NS file wrapper. One of the features we're adding in Snow Leopard is giving you explicit control over whether or not files and file packages are read in lazily or not, because usually that's a good thing to do. And if you just use the default options, you don't use NS file wrapper reading immediate, that's what you get, lazy reading of the file. So if you create a file wrapper from a great big directory hierarchy, it's not going to open thousands of files all at once. It's going to wait till you actually try and walk that. So, and the way we make that work, conceptually NS file wrapper doesn't even have a URL property, and we're not adding one. But internally, it's using file reference URLs, just like NS document, so that it can find the file when it's time to read it lazily, even if it's been moved or renamed. So, fast saving with NS file wrapper. Some documents are just large, and we have to deal with this performance issue that's caused by things like images, sounds, and movies and so on that are attached to documents. And just attachments in general, like TextEdit's rich text support lets you drag anything into a TextEdit document, and it's supposed to just hold on to it. And the way we want you to take care of this is the same way that we take care of it in general, is using file packages, which are just directories that the user sees as files. Things like the Finder and the Open and Save panels are smart enough to sense that this is a file package, even though it's really a directory, and just show it to the user as a file. And NSURL, by the way, has a resource value key for finding whether or not a file is a package and should be presented as a single thing. And the benefit of this big illusion of directories that are presented as files is that inside you get to use the file system, which is a pretty sophisticated bit of functionality. So instead of having to flatten everything out when you save files, you just create little individual files. So for example, Sketch, we're updating Sketch to use file packages as its file format. And in the Finder, there's this, in the contextual menu, there's this thing, show package contents, which I hope is just for developers. I hope users never have a reason to poke around in here. But if you do this to a Sketch document now in Snow Leopard, you'll see inside there's a property list, contents.plist, that has the properties of all the graphics in the document, and a page setup file that's a flattening of the NS print info associated with the document, and then a whole bunch of other files like text.rtf, text2.rtf, text3.rtf. Each one of those is one of the text objects in this particular document. And we have some thinking to do about this. It's easy to get carried away with this. If each one of these little RTF things is so tiny, it's maybe not worth making a separate file if it can just be put in the property list. So there's probably a cutoff somewhere there that we have to figure out. But in this example, what's most important is that there's a great big image there. It's a TIFF file, and it's pretty big. It's 1/4 of a gigabyte. So what we want to figure out is how we can avoid rewriting that 246 megabytes every time we save the document. So, and many applications use file packages. TextEdit uses it for rich text documents with attachments, and Xcode uses it for the Xcode proj files. And Keynote Pages and Numbers use them. This is just their standard file format. And a bunch of other applications, like some of the Omni applications. So that's file packages. That's what I want to make sure that you know that to use when you have great big documents with lots of attachments and stuff like that. And furthermore, if you're using file packages, I want you to use the NS file wrapper class to get at them. It's been in AppKit since before macOS 10.0. It's kind of a well-kept secret sometimes when I talk to people about it. They're like, oh, I had no idea that you had that in the AppKit. And I have no idea why people miss it. It's not that long of a list of classes, and it's kind of in the middle. So, for example, our text system uses it in public API. So you can ask an NS text storage for the NS file wrapper that represents, actually attributed string, for the file wrapper that represents the RTFD, the RTF with attachments. And what's cool, by the way, one of the things about NS file wrapper is that it composes well. And by that I mean it's easy to have file wrappers that have other file wrappers inside of them. That's its natural way of operating. So when you're building up a file package for a document to save, it's pretty easy to ask different parts of code, give me the file wrapper for that stuff and the file wrapper for that stuff, and bundle them up and put them in the overarching file wrapper. So then it also has a pretty simple API. It's good for as well as accessing file packages, just flat files. So because there's always a hierarchy of these things, at some point there's going to be leafs and they're going to be flat files. And to get the data out of one of them, you just invoke regular file contents. And you can also get the file attributes for a file out of it. And that returns a dictionary of the same sort that NS File Manager returns in its APIs that deal in file attributes. And you can get the icon too. TextEdit uses this when you drag attachments into a document. This is where TextEdit is getting the icon that shows up. And then also, when there's a hierarchy, to get the nested directories, you invoke the file wrappers method, and that returns a dictionary that's keyed by file name. And the values are NS file wrappers. So it's the class to use to access file packages. I want more people to start using it, so I want to make sure everybody knows about it. And NS Document, for instance, already has API to take advantage of it. And we're making big improvements to it in Snow Leopard. I'll talk about some of them. And going forward, NS File Wrapper is a class where we're going to put a lot of our knowledge about how to do things efficiently when you're dealing with hierarchies of files that result from using this file package scheme. So actually using NS File Wrapper, before I talk about that and how you use it to save documents fast, let me first say that document writing has to be safe. So the NS document method that's sort of at the top level of this operation of writing documents is called write safely to URL of type for save operation error. That's so explicit to put in a method name like that, so it must be important. And what we mean by safely, by the way, is first of all is reliability. So if the user kicks the plug out of their computer while something is being saved, or the application crashes, it happens, the rule is that the user must be left with either the old revision of the document, their saving failed, or the new revision, it succeeded, no matter what happens. It's not acceptable to leave the user with no revision of their document, just destroyed everything. And it's also not acceptable to leave the user with a file package that has some stuff from the old document and some stuff from the new document all mushed together, and that they have to pick apart because their power went out while they were saving. So, and the other issue that has to be considered, and it's a big deal, is privacy. The document can't contain things that the user thinks they've deleted. So, if the computer loses power and, the user reboots, and they're like, oh, good, it did save my document, and they don't open it. And they just email it to somebody, and then it turns out that all this salary information that they thought they'd, deleted before they, emailed it, oh, it looks like it was in the document after all, and somebody picks it apart. So that's a big deal. And by the way, that's why, there's this issue that comes up in some AppKit apps about what happens with revision control information that different systems like CVS and SVN drop in file packages. So, we've talked about this a lot, and we talked about it a little bit more yesterday after this question came up in Q&A in Cocoa What's New. And we're pretty sure we've decided that we're never going to do anything to preserve, these turd files that get left in file packages. We're never going to do that by default. So we might make it easier for your application to do it, but it'll definitely be a switch that you have to flip. So, because we do not want to contribute to this problem at all. And we don't want to set you up, trick you into making what very often is a mistake of, leaving stuff like that should not be preserved in the file package. So, I was talking about saving documents safely. Going back to how do we do it fast? Well, we take advantage of the fact that most files in a file package don't change between saves. And, because we're using the file system, we can just basically leave those files alone and save stuff around them. But that's not exactly what we do because of the privacy issue. So yeah, big attachments shouldn't be written to disk each time the user saves. But there's another thing we can do. Just save the changes. And this is particularly important for auto-saving. If you've turned on auto-saving in your application, and we wish everyone would because it's a pretty good feature and it adds reliability to things. The speed of saving is particularly important because the user is just typing along or dragging graphics around. And when the whole application hangs because it's in the middle of saving, that's a pretty bad UI. So, and this is particularly pronounced on things like network file systems where there's a lot of latency involved. So that's where this issue really becomes prominent. So we want to improve the situation, and we're doing it by improving file wrapper. And the first thing that we're doing is just modernizing NS file wrapper in Snow Leopard, updating it to use NS URLs, because we want to use NS URLs everywhere, and also to use NS error, because we want all applications to do good error handling and presentation all the time. So its new initializer looks like this, init with URL, options, error. And the options are kind of interesting. You can take control over whether or not it ever memory maps files in, and also whether or not it reads stuff immediately or lazy. And if you look in the header, appkit nsFileWrapper.h, there's copious comments helping you choose which options you want to use. And there's also just new functionality in Snow Leopard for nsFileWrapper for this fast saving business. Instead of just a method that takes a URL and some options and an error to write, we have an additional parameter, original contents URL. And that allows us to use hard links whenever possible. So instead of writing out entire files, when you're saving a document and the old revision is still there on disk, and you're saving a new revision, just create the directory that's the file package and populate it with hard links to the unchanged files in the old revision, and then save changed files around those hard links. And so that's what this nsFileWrapper method does if you point it to the old revision of a document that you're saving. So, and this really does work on pretty much all the file systems that we care about. So, HFS Plus and AFP and NFS, and I tried it with a Windows server, and I think we have some work to do there. But in general, it's supposed to work. NTFS supports hard links, and the network protocols are supposed to support them too. So the way you take advantage of this fast saving that nsFileWrapper offers in the context of an NS document-based application is you override the NS document methods that are already there, been there since Tiger, read from FileWrapper of type error, and FileWrapper of type error. And the one thing that you'll have to know to do is to keep the child file wrappers around and keep reusing them because they get updated with the information that nsFileWrapper needs to do this hard linking trick. So I'll show you what I mean by that in the context of Sketch. So in the NS document class, it has a method named FileWrapper of type. This is the one I just recommended you override. And what it does for this particular file format, we're calling it Sketch3. Hopefully we'll add a bunch of other features to justify the version number bump. But what it does is this method is supposed to return an NS file wrapper. And what the implementation does, excuse me for a minute, please. Sorry about that. Oh, so much better. And what this method does is it creates a file wrapper, and the way it does it is by invoking a class method on an SKT graphic, because very conveniently this file wrapper business is also good for using as a pasteboard format. So we're using this for two purposes, so we put it in one place, the common place, which is the SKT graphic class itself. So NS document creates a file wrapper, and also we have to save the page setup for a sketch document. So we just archive the NS print info associated with the document and add that to the file wrapper too, using the file name page setup, and then we return that. So what it looks like when we build that file wrapper, we pass it the array of graphics to use, and when saving a document, it's just all the graphics in the document. We create a file wrapper to hold the attachments, and each subclass of SKT graphic, will add stuff to this if it has attachments. And then we create an array of properties, property list dictionaries for each graphic, and as we're doing that, we let the graphics add stuff to this attachment file wrapper. So, and then when we're done, we serialize the property list and put this in a outer file wrapper right next to this attachments directory file wrapper. So that happens here, where we put contents.plist and attachments in the same file wrapper and return it. So each SKT graphics subclass has an override of a method called persistent properties. And if I could put commas and method names, I would. Persistent properties, comma, adding to attachments. And let's just look at one of them, SKT text. What it's doing is, if it's not already holding on to an NS file wrapper, and it should hold on to them in between saves to make this hard link trick work. If it's not already, if this IVAR is not already set to something non-nil, it'll create the file wrapper, and it decides what type it is. Is it RTFD or is it RTF, depending on whether or not this in turn has attachments within it. And then when it creates it, it just uses the NS attributed string API, file wrapper from range, and then a bunch of other stuff. So, oh, and by the way, let me call this out. This is in very poor taste. This method will return an error, and we don't do anything with it. So don't do anything like that. So, and as a matter of fact, if I check this into Snow Leopard sample code, I'll probably go back to my office and my 30-inch cinema display will be replaced with a 15-inch CRT that hums. So we're quite serious about error presentations. So yes, and so it builds this, this SKT text, for example, builds this property list and returns it. And while it's doing that, it adds its attachment to the attachments file wrapper that was passed in. So, and SKT image does this too. It puts the attached image into a file wrapper. So let me show you running. And first, let me show you what it looks like when we're not doing hard links. So let me open this document that has, a quarter gigabyte image, not huge, but still pretty big. So saving it, there's always this big pause, and there's always this spinning pizza of death. So, and during auto-saving, this is completely unacceptable. So how I turn this on, so how do I make that delay go away? Well, is by turning on this feature. And this is why you come to WWDC, is to learn things that aren't even in the release notes. NS document only uses these, right now in the seed, only uses these new NS file wrapper methods if you set this user default. So let's uncomment out the code that does that. So, and of course when we ship, this is what NS document will just do by default. So we open the same document. And every time we save, it's just instantaneous. Because all it's doing, yes, because all it's doing is every time it's just creating a new directory and writing some small files in it, and the big files, yes, I moved this purple circle so you can see that it really did save. So, and it's for the big files, it's just making hard links. So, yep, slides. Slides, please. There you go. So that was that. And by the way, that code I showed you, fooling around with the file wrappers and stuff like that, that works fine on Leopard. Just gets faster on Snow Leopard. So fast saving with NS file wrapper. File packages are often the way to go. If you have big documents, figure out how you can split your stuff up into multiple files. So most of the time, they just sit there on disk and they get hard linked to, and they're not rewritten over and over again. That avoids a lot of work. So NS file wrapper is the AppKit class that supports this, and I want to make sure everybody knows about it. Tell all your friends, because for some reason, just nobody's ever heard of this class before. So, or I think maybe people see it and don't realize this is what it's for, because the name doesn't exactly match NS file package. So, and to let you know about some future work that we're doing in this area, one thing I did not talk about is, well, I showed you that little contents.plist file in the context of a sketch document. That file getting big would be hundreds of kilobytes, which is no big deal at all. But if you're working on a core data application, for instance, and your contents file is actually a SQLite file that ends up with millions of rows in it and gets to be a gigabyte, and then there's giant attachments stored next to that, and you can't do the hard link trick because it's the SQLite file that's actually changing. That is something we're definitely investigating, trying to figure out how to make that fast too, while maintaining the reliability and privacy things that we want to make sure every good Cocoa application gets right. So, and a bunch of other improvements that we have in mind. So, in general, NS file wrapper is going to get a lot more sophisticated in the future, though it's already pretty sophisticated, even though the API is pretty simple. So, sudden termination. This is a feature I think Bertrand mentioned in the State of the Union address, and what it's all about is that we want to solve the problem that computers take too long to turn off. And what is the deal? While we were investigating, what was just kind of a nebulous performance problem, like, gee, that was slow, one of the guys on the performance team put together this pretty rigorous shutdown scenario where you open a bunch of it, it's all automated, opens a bunch of applications like iTunes and iPhoto and Pages and Safari and Mail and I think about 5 others. And it does a bunch of stuff to them. iPhoto images fly around, iTunes, looks for MP3s and all sorts of stuff. And so it's a busy computer. It's as if one had been up and running for several days. And then you just let it sit to make sure everything seems to be done working, and it really is. And then you go to shut down the machine, and it takes like a minute to turn off. And the hard drive is just grinding and grinding and grinding. And there weren't any changes to save. There weren't any dialogues popping up. And it was pretty bad. And the issue is really paging. So there's a bunch of issues. But the big one is paging, where all these applications are paging in memory so they can free it. So, and when you watch this in Shark or Sample or whatever, it looks pretty ridiculous. So, and also doing things like releasing resources, like applications working so hard, got to close that file. It's like you didn't even write anything to that file. You can just go away and the kernel will take care of it. So, and also a lot of applications in the pursuit of performance, which is always good. Some of them do things too lazily. Don't write this stuff to disk when the user commands it. Wait till later, because we can coalesce some work or something like that. And then when later means when the application terminates, you just move the performance problem to somewhere else. So that's something that we've seen a lot of in our measurement. And what we're doing to fix this and let everybody contribute to the fix is in Snow Leopard, we're adding a way for apps to say when they can and cannot be safely killed. And when an application does say it can be safely killed, during logout, restart, and shutdown, Mac OS X will just kill the app. And we're pretty serious about this. So we're really eating our own dog food on this. In Snow Leopard, all of the apps in the applications folder are being updated to use this, and even a couple in the utilities folder, because developers are people too and like their computers to shut off quickly at the end of the day. I know a lot of people don't actually turn off their computers at the end of the day, but it seems that we know this, a lot of people do. So how do people pick? Who knows? But a lot of people turn off their computers and log out and restart and stuff like that. So we're adopting this throughout Mac OS X. And what we mean by sudden termination is sudden termination in contrast to regular termination. And for an NS application, that means sigkill. It sent the POSIX sigkill signal instead of the quit Apple event. And what we like so much about sigkill, just killing the applications, is that there's nothing faster because apps can't page in memory and they can't write to disk. They can't do anything because there's not even a way to intercept this signal. So, and needless to say, for backward binary compatibility, apps that haven't opted into this get terminated the old way. They still get sent the quit Apple event, and they can dawdle and read and write files and free memory that's going away and all sorts of stuff. So we want you to adopt this new mechanism. And what you're trying to accomplish when you adopt this is, number one, you want to turn on the mechanism in your application. And then you want to disable and re-enable it as the app runs. So first you turn on sudden termination, and it's on for the lifetime of your application, but you disable it during times when, if the application were killed at that moment, user data would be lost. And by user data, we mean pretty much anything the user would notice is gone, including user preferences and stuff like that. So while you're doing this, you don't want to disable sudden termination too much, because that would make your application more likely to not be killable when it really counts. So there's no point in adopting the feature, and the first thing you do after launching the app is to disable sudden termination. You also don't want to disable sudden termination too little, because that would make your application at risk of losing the user's data. So you have to be careful. I'll show you a bunch of stuff about how to be careful. And how we can get these performance benefits without causing reliability issues. So the first thing to do is to just turn on the feature, and we've made it super convenient. You just add an entry to your info plist. NS supports sudden termination, and true or yes or whatever. So, and this is interesting because this is one of those things in the info plist that nothing outside of your application reads. Like launch services doesn't look at this. Just NS application, while the application is being launched, reads it and enables sudden termination. And the way it does that is by sending the very first message to NS process info about this stuff. It's called enable sudden termination. So, and that's the only time you'll ever be invoking that method by itself. So, because usually you'll be invoking disable sudden termination on the shared NS process info instance method, and then invoking enable sudden termination. So, and you'll be doing these in pairs, and invocations increment and decrement a counter, and when the counter is 0, the process is killable, and that means anything in the operating system outside of the process might kill it. In Snow Leopard, that means login window at logout time, but you're really not supposed to make assumptions about what might be killing your application or when. You said it's clean, it's killable, and you can't complain if something kills it. So, and you typically invoke these in pairs. So it's a lot like reference counting, actually. Disabling increments something and enabling decrements something. So, and of course, we don't want you to have to scatter invocations of these methods all over your code. That would be terrible. So Cocoa disables and enables it automatically in several places. The first one is the biggest one, and this means you don't have to worry about this all over the place. NS application disables sudden termination around invocations of send event. So an NS application pulls an event off the UI queue to handle a mouse move or a key down or whatever. NS application will disable send event around the handling of that. So that means that anything that happens that's not deferred until after the event handling is done is just safe. So, and most of the time applications are not actually handling events, by the way. So most of the time the application will be clean. We also do this in NSDocument, and that's what you're here to hear about is NSDocument. NSDocument disables it for all unsaved changes. Unsaved changes are a form of deferred work that have to mark the app as dirty until they're actually saved. And for your information about the implementation, we do this in update change count. So, which is interesting because if you're overriding update change count to defeat it and stuff like that, or adding strange invocations of it, you might run into some stuff. So this is a pretty interesting method. It's public, but there's, whenever you're overriding it or invoking it, there's virtually always something better to do. So I'm writing this up and putting it in the release notes that come out with the next seed, whenever that is, about, you just don't need that, because mostly NS Undo Manager has disable undo registration and enable undo registration. And I bet that fixes whatever problem you're using update change count to fix. So we also disable sudden termination in NS user defaults. User defaults are data too. So when something in your system in your application sends set object for key to user defaults, or you use the equivalent CF preferences API, sudden termination is disabled because it would be bad if the app were killed before that stuff was written out. So, and when user defaults are synchronized, NS user defaults will re-enable sudden termination after that stuff is written out to disk. And here's a tricky one. So there's a method on NSObject called perform selector with object after delay, and a super popular AppKit, I guess I'll call it technique. That'll be most polite. When you want to make sure that something, some bit of work does not happen in the current event loop, you want it to happen in the next event loop. It's very popular to invoke this method with a delay of 0. And because that's a form of deferred work, send event is going to return. We figured, for this case, people are always working around something anyway when they use this. For this case, for delay of 0, we'll disable sudden termination. And also because the delay is so short, right? It's not 0, but it's when the event loop is next gone through. So, but we don't want to get carried away with this. If you have something with a delay of 10, we don't know whether or not sudden termination should be disabled during it. So we just do this for a delay of 0, so people don't have to update a lot of code. And by the way, not 0.1 seconds or 0.001. Those numbers in source code, they mean guessing, basically. So I don't know, a very short time. So we're updating the documentation to let people know what a delay of 0 means. Doesn't mean before perform selector with object returns. It means right after it returns and after you return. So, and in general, you only care about this if not doing the work would lose data. There are a bunch of things where you just don't have to worry if deferred work is not done, because it's stuff like animating or whatever. If you start an animation and the user logs out, the animation doesn't get done, big deal. They said log out. Do it quick. So that's where Cocoa disables sudden termination for you. Where else should it be disabled? The rule is any time important work is being deferred. If it's not being deferred, if it's done right away before your method, which is probably invoked indirectly by NS application send event, if it's done before that returns, there's no problem because we disabled it around invocations of send event. But if you use a timer or perform selector after delay with a delay of longer than 0, or you spawn a thread or whatever, or create an operation and put into a queue, you will probably have to disable sudden termination. So when you think, oh my God, how am I going to track down all the places in my application where I do that? And as you're upgrading to this, the trick is to, well, first write an application that does not have big bugs where it throws away data when it's quit. And once you've done that, made an application that doesn't have big bugs, you'll find that you've scattered some code about your application that makes sure that things get done when the application terminates. So does your application terminate properly now? Yes? Okay, then we have a few easy places to look for termination time code. And that code points to the changes to make. That's not where you disable and enable sudden termination. For example, application will terminate. Don't bother enabling sudden termination there. It's too late. So, but let me show you some of these places where to look. So, the app delegates application should terminate, and as I just mentioned, application will terminate. So if you've written an app that works at quitting time today, you'll have code in these places to make that reliable. Also, overrides of NS application terminates. Some people put their stuff there instead of the application delegate methods. And when we're doing this to Cocoa apps, we found a case we had to deal with in Calculator where its quit menu item is not actually set up to the terminate action. It's set, that everybody else uses. It's set up to some private terminate method that does a bunch of work and then calls NS application terminate. And that bunch of work, if you want that to get done, you're going to have to disable sudden termination because that stuff isn't going to be called anymore. And also, AppKit, I don't know if you know this. I didn't know it until I started working on this stuff. NS application terminate closes every window on the way down, which is a pretty big part of this performance problem I'm talking about with a lot of deallocating of memory when it's all just going to go away anyway. So you should look at some of this stuff. If you override NS window close or some of the stuff it calls like NS view deallocation and stuff like that. If you're writing stuff to disk in your NS view deallocation method, you have some work to do before you can adopt this. But there are other design issues that perhaps you should tackle on the way. So, and also some of the delegate methods for NS window, those get called at termination time. And there's some other ones. So things like @exit and this crazy thing called the CXA @exit handler. So you can register for when your process is being exit, one more callback. And also module finalizers, which are these things you can specify on individual functions and also called C destructors. And if you don't know what these are, don't learn now because we don't want you to use them anyway. So also C++ destructors, and not all C++ destructors, oh God, just ones for statically constructed objects. So, which we kind of have been discouraging anyway, at least the ones that happen, cause C++ objects to be created at launch time because that's not lazy enough anyway for good launch time performance. So, and all the same in the frameworks you link against. So if a framework is not sudden termination safe and your application links against it, maybe you're not in such a hurry to adopt this feature. But in general, this is not that rough to make a framework sudden termination safe, to just follow all the same rules. And so, of course, we're doing that to all the frameworks that are part of macOS 10. Hunting down the @exit handlers and go, does that really have to be done when the process exits, or could it be done earlier, or does it have to be done at all? Or if it really does have to be done, maybe it should disable sudden termination so that it does happen at quitting time, except we don't want people to do that because that'll just disable the feature. So we are taking care of this in Apple's frameworks. And we've been working on this for a few months, and so far it hasn't been that rough. So, and what you're going to be doing when you find all these places that deal with things that happen at application termination time is, in general, is you're going to make your app a little less lazy. Laziness is something that we suggest a lot as a performance technique. Don't do work until it has to be done. But it can be over-applied. It can just move the performance problem to just later in the application's execution, like termination time. So here's some examples of making your app a little less lazy. And this is something that TextEdit actually did. It didn't put values that the user changed in the preferences pane into user defaults right away. We are going to change it to put values in user defaults right away. Right now, it puts them in IVARs in a controller class. So, but as things are changing user defaults, just put the values right into user defaults because it's cheap. And also, NS user defaults will set a timer. Right now in Snow Leopard, it's 15 seconds. And after 15 seconds, it'll write the values of the user's preferences to disk. And it's a nice little bit of coalescing. A whole bunch of preferences change, and then 15 seconds later, they get written out to disk. There wasn't a whole lot of redundant hitting of the disk and stuff like that. It does the right thing for performance as the app is running, and also marking it as clean and dirty at the right times. So, and when you're coalescing for performance, for example, there's a bunch of stuff that has to be written to disk each time the user makes a change with the UI, but of course you don't want to hit the disk for every keystroke. So you're saving stuff up, go ahead and do that, save that up, but don't save it too long. Do it on the order of seconds. That's enough to get the performance benefit that really counts. And by the way, this coalescing for performance, not hitting the disk for every little event, this still counts as deferred work. So you have to disable sudden termination when you start coalescing and re-enable it when stuff actually ends up on disk. So, and by the way, be as lazy as you want for things that don't need to disable sudden termination. So, if you're doing something in the background and it's just helping decide what ends up in a window, go ahead and do that lazy. That doesn't affect what's going to be written to disk or sent off to a network server or whatever. So, sudden termination. The summary is that applications, ours, yours, everyone's, can avoid contributing to shutdown delays, which are just unacceptable. The Macintosh is supposed to be like a simple appliance. When you hit off, it should just turn off. Shouldn't think about turning off, possibly contemplating, considering the ramifications of turning off. And so we're tackling this issue. And you do have to know your own code to do it properly. You have to look around for things that are done at application termination time. But when you've done that, you'll find often it's not that difficult, especially for NS document-based apps, because the main thing that happens in those is that the user edits stuff, and it will get saved to disk later. And NS document takes care of disabling sudden termination and doing that. And we already have lots of experience with this at Apple. We've been working on it for a few months and doing it to everything. The applications that are in the applications folder. Some of them still need more work, but some of them were just so easy and they're just killable. And we're also doing this, by the way, I'm just talking about NS applications today, but we're also doing this to agents and daemons in the system. They use a different system, something lower level than NS process info that actually NS process info stuff will be built on top of. But agents and daemons, like every process, is going to be killable. So when the user shuts down, just blah, everything's going to disappear. So check it out in the Foundation release notes. Foundation release notes also, by the way, include some debugging tip or two. So you're like, oh, how do I know I'm getting this right? There's an incantation you can type into GDB that will let you know whether or not the app is actually killable or not at that moment. And as far as testing this going forward, it's like, well, who's going to test what their application does at logout time? Nobody. So what we've done to AppKit, and this is actually in the Snow Leopard seed, is in applications that are killable at the time that the user quits them by choosing the quit menu item in the file menu, apps just kill themselves. So you can get a good idea and make sure that, so while you're debugging, you'll see stuff missing if you're not properly disabling sudden termination. So, and we have a whole bunch of other debugging tricks up our sleeve that we're going to put into this stuff to help people, make stuff that's reliable and fast. So, there are several ways to make document-based applications faster. Concurrent document opening, which I showed you. Taking advantage of all the improvements to NSURL that we're doing in Snow Leopard. Taking advantage of NS file wrapper improvements in Snow Leopard. And also the sudden termination mechanism that we want everybody to use. So please adopt all of these. For more information, email Derek Horn. He's our evangelist, derek@apple.com. Documentation, always read our release notes. We put so much good info in the release notes. So I like reading the release notes of other people in my own group. They're so good. So, and I think, and I don't know where you find them on the seed, but I think you do it by typing it into the search field in Xcode, AppKit release notes. So, and also our header file comments, especially things like NS file wrapper and NS document, there's a lot of information there. It all ends up in the documentation, but it shows up in the headers first. Related sessions have all already happened. They were awesome. So on Wednesday morning, there was What's New in Cocoa. On Wednesday afternoon, there was using file system APIs efficiently. And in this room, right before this, was polishing your Cocoa applications.